Good morning everyone, my name is Basita and I'm from Manipur, and today I will be representing my model. This is the Imphal area, Imphal Map Road, and the name of my project is Traffic Management in Imphal through Mathematical Set and Combination Theory. By using a mathematical set and combination theory, I have to apply and minimize the vehicle density in Imphal. And set is it is a collection of well-defined elements forming a group. For example, let us say for the set S1 equal to x1 up to x12, it is the elements which is belonging to it, and these are also the set S2 3 up to 5, and these are also the elements which is belonging to them. And combination, it is counting a number of groups which should not be repeated. And so let us start. This is the Imphal area, and this is the Kanglang. It is a historical monument in Manipur, which is situated at the center of the Imphal. In the center of the Imphal, there is a lot of traffic jam which are caused by the public transport like auto vehicles or Tata Magic, which are coming from different places. So to minimize this, I have made this project, and these are the small stations in Imphal, like different places in Imphal. It is denoted by the variable x along with the numerical. Let x1 will be the Quarengay, x2 will be the Mantripuki, and so on. And there will be also 5 metro stations. The 5 metro stations are Metro Station S1, Metro Station S2, Metro Station S3, Metro Station S4 and 5, and which I have mentioned earlier as a set S1, set S2. But now I am mentioning it as a Metro Station S1. So let us start. And each of them there will be also a small collecting stations which is belonging to each of them, and they are for the Metro Station S1 equal to, these are the small stations which is belonging to Metro Station S1. So my rule is let us take auto service from X1, the place. The auto service of X1 will come up to X2 and then will return back to the X1 itself. The auto service cannot go to any other places. Similarly, the auto service of X2 will come up to X3 and then will return back to the X2 itself. The same rule will be applied to all the small other stations also, and there will be also a circular bus service for Metro Station S1. The circular bus service will travel passing through all the small stations which is belonging to the Metro Station S1, and the same similarly the rule will be applied to the other Metro Station S2, S3, S4 and 5. And I'm taking a combination theory, and by counting there is a total number of 5 metro stations. I have to select two groups. It is mathematically proved that it has 10 groups, and the 10 groups are here. And there will be also having a small common stations between the metro stations. Between each of them there will be also a common stations. The common stations for S1 intersection S2. Intersection, it is a sign and it is common. S1 intersection S2 equal to X9 and X8. X9 and X8 is the small stations which is common to both of them, which belongs to both of them. And let us take an example. The person of X1 wants to travel up to X13, but actually the X13 belongs to the metro station S2 here. So we have to find the common small stations to both of them. But the common stations to both of them is X9 and X8. It belongs to both of them, so the persons of X1 will travel up to X9 and X8 by means of circular bus service or auto service. Since the two small stations also belongs to the Metro Station S2, the person will be reached up to X13 by a circular bus service or auto service. And the significance of this project lies in its mathematical solution in such a way that as long as the common intersections of all the passenger vehicles are becoming less, vehicle density will be minimized. Let's say if the number of the intersection between the two metro stations is less, then the vehicle will be minimized. Let us say the auto service of X1 will not be available to any other small stations. That is the conclusion. Thank you, sir.